Now, welcome my viewers. So we have another one in this place, which is electrical what power, right? So the last time we talked about electrical energy, right? So I want to talk about what electrical power now today. So electrical power, I don't want to waste time, okay? So electrical power, let me use EP for it. It's equals to what the work done. Formula for what is work done, electrical work done. Let's take it as electrical work done, okay? Take it as electrical work done, electrical what work done over what over time. Now, when talking about electrical work done, same thing as what as electrical what energy. Okay, but the work done equals to what energy. Okay. Now the work done simply means that when we have the work done, so we have electrical power equals to electrical work done is what it simply means we have the current that's something as well as electrical energy. Okay, which is current, volt, and what and time. That's electrical work done for you. Or we call it what electrical what energy. Then over the time that we have here. So in that case now, the time here cancel what is here. So we have electrical power equals to current and what and volt. Now this is how they got electrical power as what? As current and what and volt. Let's take that as question what? Equation 2. This is question 1, equation 2. Now some of you are just seeing something like this in your textbook. I don't know how come they form the formula or how they derive it. This is actually the equation here, okay? Now when you have electrical power as current and volt, so which simply means that anything have to do with what? Deal with electric. You must always remember your Ohm's law, right? Which is what the voltage equals to current and what and resistance. So now in this case we have to put for what for voltage to mean that so that we can actually have what energy for what for it. So we're going to have electrical power equals to when I put for voltage now, it means that I will have current left first, the bracket. Voltage is now what current and resistance. So we have current and resistance. So we have electrical power equals to what current square and what and resistance. This time this give us I square divided by what resistance. Take that as question 3. Now we've substituted for what now for current for voltage rather. So let's substitute for what now for current because we have current in this first equation here. So you can see that we have voltage here and I put for voltage we got this. The next one we have current in this equation. So it means that I will make the current the subject here. Okay. So that means that I'm going to make the current the subject. I'll V equals to current and resistance. So I'll remove this arrow. I'll remove the arrow. So we have cancel that this. We have what the current. We have current equals to what voltage over what over resistance. So now in that sense now I'll put this value now volt over this variable here volt over resistance into what equation 1 again. So I think I'm going to have electrical power equals to what is our current now? Current has become volt over resistance. So we have volt over resistance then times we have extra volts there. It means that electrical power now becomes V square over what over R. Question 4. Now this is the equation under what now? Under electrical power, right? So let's now try to what to relate it to what to electrical what energy. From electrical energy now we say we have current, volt, and we have time. Don't forget that current and volt is for power, right? Which means that I can say have the electrical energy. I can say that since we have power equals to what current times voltage, so we have electrical energy as P times T. Means that electrical energy can also be what can also be power times what times time. Okay. So I want to believe that you guys you find this class very interesting, right? So don't forget to like my video, share, and comment. Thank you.